This is the chapter 5 part 2 review. It's about triangle inequalities, mostly in one circle and one triangle, except for with the hinge theorem. That one does have two triangles, but for all the rest of them, you're focused on just one single triangle. So first question is asking, is it possible to construct a triangle with 10, 11, and 30 as the sides? Remember, you wanted these two smaller ones to add up to be bigger or greater than the large one all by itself. So if you add 10 plus 11, that's 22. And if you compare that with 30, that's not greater than 30. So is it possible? No. And then explaining why. The two smaller sides aren't more than the largest side when added together. Second one, is it possible to construct a triangle with sides 5, 3, and 4? So here's my two small ones, 3 and 4. Add those two together. That'd be 7. Now that one is greater than the 5 by itself. So that would be a yes. You could make a triangle out of that. And explaining why. The two smaller sides add up to be greater than the largest side. You don't have to give the same exact explanation that I gave, but something along those lines, where you added the two small ones and made sure that they were greater than the largest side all by itself. Number 3, it says write the sides from least to greatest. To compare the sides, we need to know all the angles, so we're going to have to find this third angle where the B is at. So we need to subtract these from 180. So 180 minus 60 minus 70. My calculator. I got 50. So now that I know all three angles, remember small across from small, medium across from medium, large across from large. So I said start with the least. 50 is the smallest angle, 50 degrees. So I come over here, that'd be AC has to be first. And then after that, that one is less than the next side, which is across from the 60. Go across from there. Now we're at BC. And BC is going to be smaller than the largest one, which goes across from the 70. So it'd be AB. So that would be the order from least, then the middle one, and then the greatest. Number 4, it says write the angles from least to greatest. So now we have the sides. Luckily, we have all three of them, so we don't have to go looking for the third side. But it's still going to be small across from small, medium from medium, and large from large. Between 13, 15, and 17, 13 is the smallest side. Coming across there, angle B has to go first. Since we're going with least to greatest, that means that's the smallest one. The next one's going to be bigger than that. 15 is the next biggest number, so if I come across, I get to angle A. And then the last one, 17, is the largest number, so if I go across from that, C has to be the largest angle. Next one, it says write the sides and the angles from least to greatest. You don't have the third side over here, but you know that it's the hypotenuse on a right triangle. And the hypotenuse on the right triangle is always going to be the biggest one. So you could use Pythagorean theorem, but since I know that the hypotenuse is the biggest, and I don't need to know the number, I just need to know which one's the small, medium, and large, that's good enough. If you want, you can use Pythagorean theorem, find out what it is. I'm not going to. And then it says, when it comes to the sides, you go, okay, 8's the smallest one. So YZ has to go first. That's the least. And then after that, we've got the other leg of the right triangle, which is the 15. That's on XY. So that's in the middle. And then the largest side was this one over here, the hypotenuse, which is xz. Then it also asks for the angles. So we're going to go across. 8 was the smallest side. Come across, we're at x. Remember, you could also just use the other letter that we didn't use. So we already had yz here. That's why x is there. If we did that here, we already know z is going to be the next one. And then the last, we have x and z already. So that means y has to be the very, very last. So it's angle x, then angle z, then angle y. Next, it says circle all the ones that could be the third side. So I kind of mentioned this one when we were doing the examples in class. This is where you would want to do the range, even though it's not asking for the range. So if you subtract 20 minus 14, that's 6. If you add 20 plus 14, that's 34. So x has to be somewhere between there. So x has to be less than the 34. Remember, this would be your range. And then it can't be 6, and it can't actually be 34 because there's no equals on these. It's just less thans. So anything between those numbers. 2 is not going to work. That's too small. 3 is not going to work. 10's okay. 10's between those two. 35 is too big. 7's okay. 20's okay. 34 doesn't count because remember, we don't have an equal on this, just less than. 18's okay. 0, too small. 6, again, it's not equal, so 6 doesn't count. And then 31, so we would have 10, 7, 20, 18, and 31. Next part, we're just going to do this first piece. We don't have to go looking at individual numbers. So it says in the drawing, instead of a drawing, we have 8 and 10 inches are our two sides. So 10 minus 8, that'd be 2. 10 plus 8, that's 18. X has to be less than the 18, so it has to be greater than the 2. If you read it backwards, that says x is greater than 2. Reading it backwards. Ta-da! There's the range. Number 8, which one of these cannot be the side lengths of a triangle? So remember, this is just like what we did on the first two problems, where you're finding out could it make a triangle or not. So if I add 15 and 15, that makes 30. 30 is not greater than 31. That doesn't work. So that, which one cannot? That cannot be. If we add 12 and 12, that's 24. 24 is bigger than 21. So that one would work, but we want to know which ones cannot. So we're not going to use that one. And then the next one, the two smallest sides are the 18 and the 12. If you add that up, that's 30. 30 is bigger than 25, so that one also works. But remember, it says cannot. And then the last one, 4 and 4 would be 8. 8 is bigger than 7. So 8 would work, but we want the one that doesn't. A is the only answer because it's the only one that does not actually work. Kind of weird, I know. Careful with those directions. Okay, explain the hinge theorem. You can put it in your own words, but the basic idea is that if you have two triangles, I'm going to use symbols so I don't have to write so much, that have two corresponding, I'm going to put CORR for corresponding, congruent sides. So for example, over here on number 11, we have 9 and 9, and we have 10 and 10. So 9 and 10, 9 and 10, those are corresponding because you have a 9 on each one and you have a 10 on each one. So there you go. If you have two triangles that have two corresponding sides, then the triangle with the smaller third side will have the smaller included angle. So remember, it was small across from small, and then on the other one it was large across from large. Okay, the next one, explain the exterior angle inequality theorem. So that was the one where, because we know that we add the two remote interior angles to equal what's outside, we know that the remote interior angles will always be less than the exterior angle on any triangle. And like I said, you don't have to use my words, but it's that idea that these two interior angles, the remote ones that are from over here, these are always going to be less than what's on the outside. So the remote interior angles, either one of these angles over here, are always going to be less than whatever you have out here on this exterior angle for any triangle. Backside. It says compare CD with CA. So if you come down here, CD is across from 75, CA is across from 72, CD is across from a bigger number, so CD is greater than CA. Which theorem did you use for that? That's the hinge theorem. Did I answer that on this one? Ooh, I almost skipped this one. My bad. Okay, this one does the same thing. So if you go angle 10, sorry, side over here 10, matches that 10. And then this 9 can match with, we have two 9s here. So if we want to measure it P and Y, I'm gonna go with this one over here. So I can keep that Y included. Okay, so we're looking at this angle and this angle with those sides. So I'm highlighting it to make it easier to see it. If I go across from Y, I get 9. If I go across from P, I get 8. So P is across from the smaller one. That means it's less than. And again, that's hinge theorem. Number 13 says name all of the angles that are greater than 7. I come over here, 7 is on the interior, and on top of that it says the ones that are greater. So remember, if we're looking for the ones that were greater, that means this one is an interior, one of the remote interiors. I'm gonna put a little note right here, just INT, to remind myself that that's an interior angle. So that means from this 7, I'm looking for the remote exterior angles. So not the 6, because that's not remote, it's right next to it. But the 4, or if I come over here, the 3, or if I come over here, the 1. So I've got 1, I've got 3, and I've got 4. On the next one, it says name all the angles that are less than 4. So if they're less than 4, this is my big angle, this is my exterior. So angle 4 is out here. That means I'm looking for the remote interior angles. I've got 7 and 9. Now you have to watch out, because this one does not say according to the exterior angle inequality theorem. So there's actually a few more answers on this. If you remember from way back when, we had vertical angles, and if 7 and 8 are vertical angles, they've got to be exactly the same. So if 7 was less than angle 4, then 8 is also less than angle 4. And then same thing with 9. So we've got 9 over here. The vertical angle for 9 would be 2. So if 9 is less than angle 4, 2 is also less than angle 4. So it'd be the 7, the 9, the 8, and the 2. And that's because it doesn't specify only by using the exterior angle inequality theorem. Watch out. Okay, the next one, oops, I need the drawing. Name all angles greater than angle 9. So again, if it says greater, remember, that means this is the small one. This is the interior. So if this is my interior, I'm looking for those remote exterior angles. So 6 is made out of an extension from this side and the side of the triangle. So 6 is an exterior angle that is remote. So we got that one. And then if we come over here, we have 9. And then over here we have this extension and the side of the triangle. So this 4 right here, that's also an exterior angle. And then for number 14, it says which one lists the sides in order from least to greatest. So we're missing this third angle. We're going to want to find it. Subtract from 180. 180 minus 91 minus 20 is 69. It's so small that I'm going to have to write it outside right there. So 20 is the smallest angle, go across. XB has to be first. So that's good. This one's first. And then 69 is the second biggest angle. Go across from that. We're at BD. Yep, that's matching up. And then the third one, 91, goes across from XD. DX, there you go. So this one has to be the answer. And that's the whole review. So all of the concepts are on this review. The review has, I believe, 20 questions. The actual test has like 20 questions, but it's because some of these have more than one part. So all of the concepts, they're on here.